The atomic model has evolved a lot since the early theories about atoms. One of the first representations is proposed by Democritus, a philosopher from antiquity, around 400 years before the Common Era. According to Democritus, matter is made up of tiny particles, invisible to the naked eye and separated by empty space. He calls the particles atoms, from the Greek word atomos, which means indivisible. About 100 years later, the philosopher Aristotle claims that there is no empty space in matter. Matter is continuous and infinitely divisible. At the time, Aristotle's theory was the most accepted. Today, we know the model proposed by Democritus is actually closer to the truth. Let's fast forward to the 1800s. John Dalton built his model based on observations made by different scientists. Today, this model is referred to as Dalton's atomic theory. His model is based on 4 main points. Atoms are invisible and indivisible particles. Atoms of a given element are identical and have the same mass. Atoms of different elements have different properties and masses. Atoms of simple elements combine to form new products. Around 1900, Joseph John Thomson discovers the existence of a negative particle, the electron. His discovery leads him to hypothesize that the atom is a positive sphere embedded with negative particles. For the atom to be neutral, he proposes that the negative charge of the electrons must be cancelled by the positive charge of the sphere. According to Thomson, the atom is no longer indivisible, since electrons can be separated from it. This model is called the plum pudding model, after the traditional British dessert. For the purposes of this video, raisin bread is used to illustrate the same concept. The dough represents the positive matter, and the raisins represent the negative electrons distributed inside the bread. A few years later, Ernest Rutherford, Thomson's student, proposes a new atomic model. He discovers a new particle, the proton. His model is based on 3 points. The atom is mostly made up of empty space. The atom contains a massive nucleus made up of positively charged particles called protons. Electrons revolve around the nucleus. Rutherford realizes his model has some limitations. It does not explain why electrons do not fall into the nucleus, nor does it explain how positive charges in the nucleus can remain so close to each other despite repelling each other. Then Rutherford's student, Niels Bohr, attempts to clarify his professor's model. He imagines that electrons move in precise orbits called electron shells. This model is called the Rutherford-Bohr atomic model. A few years later, James Chadwick discovers a new particle, the neutron. The neutron is located in the nucleus, and it has no charge. It keeps the particles of the nucleus together. Chadwick improves the Rutherford-Bohr model by explaining why the nucleus is stable, although its positive particles repel each other. The model is called the Simplified atomic model. Even today, the atomic model evolves as new information comes to light. New particles making up the atom have been discovered. Scientists still have a lot of mysteries to unravel to understand the matter surrounding us.